In this section 4.3, we're going to be talking about Python matrix library. So there are two main libraries that you can use for matrix multiplication and then all these operations that you want to do on matrices. So the first one is NumPy. We've actually done many NumPy operations already, right? We use like a lot of the functions already, and then pandas. So these are the two main libraries. The first one, say, we can use NumPy first, right? And then we can even use NumPy array to actually create 2D array and then to represent a matrix. So say we start with this, right? 1, 2, 3, right? So you have this as just an NumPy array. So we can look at, so it's 1, 2, 3, 4, 5, 6, right? Look at the type of it. It says NumPy ND array. So that means like it's, multiple dimension, n-dimensional array, right? So, this is our A, right? So what if we want to do like the A dot, transpose? So this will actually give us a transpose, right? 1, 4, 2, 5, 3, 3, 6, right? And then if we want to transpose it back, then it's going to be our original A. So the same thing would do B, right? So, and then here is actually a really good, very useful one, np dot, and then you're taking a dot product of A, right? So A, pretty much A times B, but you have to do B dot transpose because remember, in matrix multiplication, you have to have the number of columns, right, matching with the number of rows in the second matrix. So the first matrix number of columns should match with the second matrix number of rows. So that's why you have to take the transpose, and then you get this, right? So now say I want to create another matrix, right? That's going to be like, say, I want to take the, every number to the power of 2 and then create that as a matrix, right? And then, you can actually do it this way. So C, remember, it's 1 to the power of 2 to the power of 2, so 4, 3 to the power of 2, so that's like 9. So, or you can do something like, if I want to create D is equal to, A minus 1, right? So this will give me, right? So 0, 1, 2, right? So you're subtracting 1 from each. So that's why NumPy is very useful because you can do this type of, it's called broadcasting, right? So you can do this, and then when you do this, it's going to be applied to every element in this array, 2D array, right? So as you can see, you can actually do many things with this. But let's see one of the example is C dot diagonal, right? So you can do, so this will tell you the diagonal element. So C is 1, 4, 6, and so because this is not like, this is a 2 by 3 matrix, so the diagonal is going to be 125, right? So if you have actually, say, if we construct something that's more like, say, C2 is equal to np dot array of, something like 1, 2, 3, and then I'm going to do 1, 2, 3, and I'm going to do like another 2, right? So this is actually going to be 3 by 3, right? So what if we look at C2 dot diagonal? It's going to give us 1, 2, 5. So you can actually see, okay, this is our diagonal 1, 2, 5, right? So great. So now let's say we can then convert this. Remember, this A right now is 2D array, right? NumPy 2D array, but we can actually convert it to matrix. So this NumPy has the matrix representation as well. So you can actually just do it this way. And now let's look at A, right? So A, it looks the same except for this is array, this is matrix. So that's the only difference, right? So, you can actually look at the type of it. And then it's going to tell you, yes, it's a matrix. It's not an array, right? So do the same thing for B and C. And now this is like actually another function that you can use, returns indices of elements that are non-zeros, right? So let's look at A again. So our A is like this, right? So you can see it's actually, everything is non-zero. So it's going to be just returning everything, right? So, and then A minus B, right? So this will just tell you the difference between A and B, right? Because both are matrix, therefore the end product will become a matrix as well. So plus, you can actually do A plus B, and then A dot B, right? Remember how we did the dot product? We took np dot, right, in here, np dot, and then A comma B dot transpose, right? So we got the same thing in here, right? But this is array. However, how we did it in here is actually a matrix. So it's the same thing, but you can actually use different representations. One is a 2D array, the other is a matrix, right? An NumPy matrix. So you can actually look at the sum, right? Like sum is like this, right? Sum, and then of course you can look at mean, right? What if I want to say a dot mean? Right? So this will tell me, okay, the sum of that is just, right? So let's see, a, let's print a, right? So this is our a, and then sum is like adding this up, everything up, and then mean is just taking the mean of it, right? So yeah, mean is 3.5, and then you can do like a lot of other things like standard deviation, you know, variance, and all these other, you know, things. Bar or variance? Yeah, bar. Okay, so cool. So now you can actually convert this A. Now it's in NP matrix into a pandas data frame, right? So if we just do it this way, look at ADF is going to be a matrix, you know, pandas DF. So we're gonna actually look at the type. You can see, right? So it's a pandas DF, right? Data frame. So you can actually use a lot of pandas embedded function to process this, right? You know, do multiplication or group by, right? So, but if you want to just look at a pure matrix calculation, then I would recommend you using NumPy, either in 2D or NumPy matrix, right? So it's just like you can see that you can do a lot of broadcasting, you can do a lot of easy, you know, like this, right? Operations on several different matrices.